Water is our most precious and arguably most undervalued natural resource. Not only is it essential to our existence and all life on this planet, it is vital for food production and economic development. Moreover, water plays the most fundamental of roles in our weather and climate. However, with a growing global population and an increasing demand for modern lifestyles, our water resources are constantly under threat from overuse and pollution. In addition, the effects of increased human activity are changing our climate, which among other issues are thought to be leading to an increased frequency of extreme weather, causing floods, landslides and drought. If we are to secure our future on Earth, the need to understand and monitor our environment has never been more important. The best way to do this on a global scale is from space. These data are urgently needed to understand more about the Earth's finite water resources and indeed whether its cycle between the oceans, the atmosphere and the land is actually speeding up as a result of global warming. The information that SMOS will provide is also needed to contribute to climate, weather and extreme event prediction. Salt in the oceans and water in the soil may seem unconnected, but in fact they are both intrinsically linked to the Earth's water cycle and therefore weather and climate. Soil moisture forms an important component of the terrestrial part of the water cycle, being a key factor controlling the exchange of water and heat energy between the land and the atmosphere through evaporation. Along with temperature, the varying saltiness of the oceans is an important driver in global ocean circulation patterns. This conveyor belt-like circulation is a crucial part of the Earth's heat engine and vital for regulating the weather and climate. Ocean salinity is largely controlled by a balance between evaporation and precipitation, but processes of seawater freezing and melting are responsible for increasing and decreasing the salinity of the polar oceans. It is the cold, dense, salty waters of the Arctic, Europe's mild climate.
Water is the main driver for the exchanges between the atmosphere and the soil, and by such, monitoring these changes help us have a better weather forecast, weather prediction, because this is the goal, or better monitor climate changes. So by being able to measure accurately the water available in the skin of the Earth helps us have a better understanding of the future weather.
A number of such field exercises over land and sea have already been carried out and will continue after launch as part of the validation program. The technology that the SMOS mission employs is expected to make a breakthrough in remote sensing techniques, provide much needed data for understanding the Earth's water cycle, and help with the prediction of weather and long-term climate change.